Hey guys, what's going on? Yeah, so today I'm going to talk about a little bit of genius. That is a party trick. That's not genius. True genius and genius is a term that's being thrown around quite randomly and pretty loosely. First off, if anyone's ever told you that you're a genius, you're likely not. That's the harsh truth. I'm not a genius. It's just the sooner you stop thinking in terms of how smart you are or how not smart you are, the better you will progress. And quite frankly, there are more subject matter experts than there are true geniuses. And when I say true genius, what I actually mean is the ability to apply several different concepts all in one. Let me take this Rubik's Cube for instance, right? It's inherently simple and requires pretty simple geometry. You need to be able to understand how the geometry of it. If you want to bring something from the bottom layer to the top, flip it up top. If you want to bring something from the corner layer to the side, you just do some kind of cool move. But all it's really doing is just basic geometry. These are party tricks. These aren't really a true measure of your genius in any way, whatever you have been told. But the sooner you stop thinking in terms of smartness in general, the better you will progress. It's important to know where your true intellect really lies, what your level is. The sooner you know what your intelligence application level is, genius application level, that's more important how you apply your genius than how smart you are. So that's why there's only 1 in a million people who are true geniuses, and that happens. It's an anomaly. But most people, they're subject matter experts. Then they are actually true geniuses. So why is it important to know your limits? Because the more limits you know, if you understand how you are not thinking, makes it easy or develop on how much better you can think. And part of my series is the hard questions for the SATs. Now, SAT in general isn't really a hard test per se. It's not hard. But every once in a while, there will be questions that are astronomically hard, and not necessarily in terms of concepts, but in terms of application of the concepts. And what is the purpose of these questions? Sometimes these are experimental questions. You could Google hardest questions in SAT, and you probably find stuff that is extremely hard. And these aren't really hard questions. They're more like subject matter expertise level questions. That one's decent, but I have seen some really hard ones, and they're not hard like it'll take you a long time. It's just really hard to grasp and wrap your head around the concepts that are involved. Now, why are these there? These questions are sometimes there in your SAT exam, and everybody rants about how hard they really are. And it's true, they're quite hard. But they're there to find and hunt that true genius. And your colleges actually know a lot about your score than you do. They know what type of questions you answered and what type of questions you got wrong. So if you're in like a tight spot, like sort of like a competition, and the schools, they sometimes will drill down to see, hey, what format of SAT he took and what type of questions he or she got correct or incorrect. And there's times when there will be questions that are called headhunter questions, or sort of like a bait type question. They really isolate the true genius. And even if you get a good guess and get it right, they will know and cross-reference your answers with what you got wrong. So even if you made a guess on these kind of questions and then you got something that is absolutely trivial wrong more than once, they will know that, hey, this was probably a guess. But every once in a while you will get these questions, and they are, you will be surprised to see how simple they are and what kind of concepts apply to that. So our question of the week, or the genius question, was this one. The domain of the function f(x,y,z) equals 100x plus 10y plus z is defined for all non-zero positive integers less than 10. If a number is chosen at random from within the range of the aforementioned function, what is the probability that the chosen random number satisfies the equation z equals y minus x? Okay, so if you want to attempt this yourself, pause this video and take your time in solving this, and then come back to what my solution is. So I'll give you a few seconds to pause this. Okay, so when it comes to first identifying that, hey, is this an experimental question, or is it a really hard question? If it's completely within the first minute or 30 seconds, if you haven't really pointed out the pulse of this question, you may not even know how to answer it. So you'll be wasting your time there. But here, my 7-year-old daughter actually looked at this question a few days ago and said, hey, Papa, this right here looks, what is this? This she's learning place values. And it's truly wonderful how the mind of a child works. It's simple, as Master Yoda would say in one of the movies when Master Obi-Wan lost the planet Kamino. And he went to Master Yoda and said, hey. And then Master Yoda asked one of his disciples, and they're like, hey, maybe someone stole it, someone erased it from the archives. And then he goes, truly wonderful mind of a child is. And that's quite true. So she pointed that and said, hey, this looks like place values. It looks like these are the hundreds, tens, and 1. You know? And it says right here, non-zero positive integers less than 10, which would mean numbers 1 through 9. So, quite frankly, what are we looking at here? We're looking at a 3-digit number between 111 and 999, correct? So that would make a total of 729 numbers. How? 9 times 9 times 9, because you have numbers 1 through 9, so that's 9 numbers. 9 times 9 times 9, that would be 729. So the domain of the function will have a result from numbers 111 to 999. Now, before you jump to the answer D, it seems a little too simple. So if you are one of those 1 in a million students who already know how to solve this, and congratulations, you're 1 in a million. You're truly gifted. But people like us, we had to think for days and ends on this before it actually dawned on me. This question is actually from one of the MIT circles that sort of like an inner circle floats around some of these types of questions. They're just out of the box thinking. And it took me a long time to finally get the pulse of this question. I exhausted. Well, first off, I approached it like a coder. How else would you approach it? If you were a computer programmer, you would be like, hey, this is a piece of cake. Once you figure out that there's that many numbers, so I'd be like, hey, for numbers 111 to 999, I'm going to just write a dynamic loop, then loop this thing, then loop 1 through 9 for x, y, z. If z equals y minus x, then I tally that number. then in the end, I'd be like, hey, my answer would be what? Answer would be tally divided by 729. So as a programmer, this can only be solved programmatically in like 2 minutes. On your SAT, you'll get a question like this. It'll probably be with 3 or 4 questions from the same set of data. So obviously, you don't have calculator. This is a no calculator section. This would be on no calculator section. So you don't have programming. But you figured out that, hey, the domain of the function is from numbers 1 through 999. So what is the purpose of z equals y minus x? Now, think like a child here. You'll be like, okay, now that this is a number, let's just pick a number. Let's just pick a number, 323. Okay, z equals y minus x, so 3 minus 2. So they're looking for basically the sum of these two numbers to be equal to that. So what would be one of those kind of numbers? It would be like, let's say, 121. 1 plus 1 equals 2. So this is x, y, z. So y minus x equals z, or x plus z equals y. Now, right here, when I started thinking about what kind of numbers would satisfy this, all of a sudden, what did this ring a bell? What kind of numbers they have like this, the pyramid. It's like the divisibility by 11. So the numbers who have this kind of behavior are divisible by 11. So hey, all of a sudden I grabbed the second pulse, okay, not even more answer to 91. Then it occurred to me, is this the only criteria for divisibility by 11? No, it's not, because first off, the number, let's take a number that is divisible by 11. That would be 209, right? And 0 is not even part of the domain. So this number wouldn't even be in this list. So, okay, so we know that guaranteed that the numbers that have this kind of behavior, that where x plus z equals y, they're divisible by 11. But some of them, they have a different kind of ruling. So 9 plus 2 is 11. 11 minus 0 is 11. So that's divisible by 11. But just how many numbers there are that are divisible by 11 from this one to 999? I'm just going to take a wild guess. What is the last possible number that could be divisible by 11? It would be 990, correct? Okay. So if you divide this by 11, we know that there are right about 90 numbers that are divisible. 90 numbers that are divisible by 11. Right about there. But we're looking at 91 divided by 729. So what's that about? So next thing I think about is, what is the purpose of these things? So we know that obviously there are less than 91 divisible numbers, because 90 is the last number divisible by 11. So it cannot be, this cannot be the ratio. Now what is this ratio? Right about 1 through 8, correct? The ratio is about 1 through 8. So if that's not true, 1 out of 3 can't be true, and obviously this can't be true either, because this is just about 1 out of 3 ratio. So this is out. This is what we're left with, 44 divided by 891. So by simple elimination, the answer would be that. But I guarantee you, if you chart this all out, you will come up with that. So what's the purpose of 891? So let's say you're one of those 1 in a million who knew exactly how to do this. So 891 and 44, it's the same as 4 divided by, let's see what, 80, right? 4 divided by 80, 81, stress about what? Yeah. So 81 times 9 would be 729. 4 times 9. So this is the same ratio here as 36 divided by 729. So I guarantee you, if you make a list of all the numbers from 111 to 999 that are divisible by 11 and also satisfy this rule right here, you will come up with 36 numbers. And that was very beautiful. And this is one of the best questions that SAT has thrown us at in the circle. And don't feel bad if you can't do these kind of questions. These are 1 in a million questions, and you either get it or you don't. But what this really does is enhance your thinking. It enhances your thinking. How you learn how you are not thinking to learn how to enhance your thinking. And that's part of it. So stop thinking in terms of this guy is a genius, I'm a genius, a super genius. There's no such thing. There are subject matter experts and there are true geniuses. This is the kind of stuff that a true genius would instantly get, but doesn't mean that you can't get there. This is just a trigger to get your juices, your mind rolling. So that's about it. Just work hard and stop thinking about being a genius or not being a genius, and just keep working on being the better version of yourself, and keep working on thinking differently in all sorts of ways. That's it for today. Thank you for watching.